Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk, the #1 industrial-related podcast in the universe that celebrates industry professionals all around the world. You are bold, brave, you dare greatly, you innovate, you collaborate, you solve problems, and that's why this platform celebrates you, because you deserve every bit of the celebration. And we are broadcasting on site here at DistribuTech. This is in Orlando, Florida, and it is, again, a collection of problem solvers that are dedicated to making the world a better place. We are very fortunate to be here, and we're very fortunate to have Sabine back in the hot seat. She is with Siemens Grid Software, and we're going to talk about how things have changed since the last conversation. Let's get cracking. Hey, Sabine, how are you?
Hey.
Thank you for your patience. Thank you for your flexibility. I was so excited. I just said, oh, I get to talk to Sabine again. Because the last conversation was great.
I was looking forward to this one.
And were you?
Yeah, I were.
That's cool, man, because it never goes unnoticed when it comes to an event like this and you see the innovation that is happening and how it's just, if you're not in the game, if you're not actively pursuing solutions or ideas or collaborating, it only takes a week and you're out of sync with what's going on.
Absolutely. I mean, the pace is just ever increasing. It's amazing. And if not here, like, where would you feel it? It's like physical, that you could feel the pace and the power that's in this industry.
So with that said, we spoke about grid modernization last time. It's still Siemens Grid Software, which is still the organization. And take us through what has changed from a couple of years back when we had this conversation to where we are today, because it's way above my pay grade.
I mean, when you earlier said grid modernization, that's what we talked about 2 years ago. I would say the challenge has become so much bigger that the word grid modernization just doesn't keep up with it anymore. Wow. So if you think about what's going on, I mean, we see a 3x in expected growth in electricity demand. If that's true, we need to double or triple the electricity grid capacity. And tripling or doubling capacity while at the same time the whole system is turned upside down. So you get millions and millions of DERs added to the network. So the complexity is rising as fast as the capacity. And we just got to find completely new ways of how to manage this grid, how to keep it stable, to keep up with the pace, and to have the foundation for almost everything in this society.
See, this is what's interesting. Three times. I was with Southern California Edison. I was a transmission lineman, and we were talking specifically at that time, that's years ago, about reconductoring the existing transmission lines, because we needed to push more through. There was greater demand, push more through, whatever it might be, right? And today we still are talking about that. It's as if we cannot keep up, and the demand is even far greater than it was back then.
I mean, we were discussing these days, I mean, electrification of everything means electrification of transport. So electric vehicles, no longer fueling with the tanks with gallons. You talk about electrification of heating, heat pumps programs in the US, like 25 governors announcing 20 million heat pumps added, but in 6 years. 2030 is in 6 years. So the amount of electricity demand will just rise sharply, and we were debating whether the demand that is added by artificial intelligence is actually already accounted for, or whether it's like even adding to this.
Hold it, I don't understand when you saw it say the demand of artificial intelligence. What do you mean by that?
I mean, today the amount of electricity that data centers are consuming is like at nation scale. So it's the same than a large country. And now when you look at the processing capacity and the electricity demand for AI, it's 5 to 10 times what it used to be. Like those chips consume 5 to 10 times the electricity than regular ones. 5 to 10 times the demand of data centers is like adding nations to the demand. And I think when we talk 2x, 3x, this is not accounted for.
Wow. You're blowing my mind, because I can't wrap my little mind around all of that. And with the pressure of net zero, trying to figure out that equation in light of all of the demands that are going to be required of the grid. What for the individual out there, now that I'm not happy and I'm uncomfortable with the realities of that exist out there, what are some solutions? What is Siemens Grid Software? What's that solution look like?
Yeah. I mean, first of all, I want to say that undoubtedly this means building new transmission lines. This means stepping up the distribution grid, and there's a massive amount of investments. We talk hundreds of billions going in there. So that absolutely is key and is fundamental. And with whatever software solutions, you can't get around that. But you got to make sure every dollar that we invest there is the right dollar. You can't afford stranded investments. You can't afford to be slow. So what Siemens Grid Software or software in general can do is utilize the existing capacity up to their physical limits. We don't do that. We are blind.
You optimize.
Yes.
Extract all the value as you possibly can with these existing assets, and therefore you don't have any stranded component to it.
Correct. At the moment, we don't know how much transformers and substations are really loaded. We don't know the effect of DERs on the network. So for a pole-top transformer, a second EV on the same line might just be enough to blow it up. And if now you have several pole-top transformers rolling up to one substation, what's that gonna make? So unless you know what's happening, you can understand what's the right investment. Do I replace this in this way or another way? Is this enough capacity? Too much capacity? We don't have the data.
I was just going to say, just when you just use the analogy or the use case of a pole-top transformer, how many pole-top transformers exist out there? How much information it needs to be gathered to be able to have that insights, that visibility into that asset, that pole-top transformer, that nameplate, whatever it is, so that you can properly say, it's capable of X.
Yes.
No X. It's right at the limit.
Yes.
I don't even know where you begin.
I can make the problem for a second larger before I come to solutions. So if you're overheating transformers and don't let them cool down enough, and you don't know when that's happening, the lifetime of a transformer can go up to 1/10 of the original lifetime. So you will have unexpected failures in a row without knowing that this is coming about. And if you add to that equation that the current supply chain is 2 years for a new transformer, you get scared.
It's insane. I'm ready to curl up in a ball there, because all I care about as a consumer of power, which I am, I want it safe, clean, whatever. I want it to not flicker.
You want your house to be warm, you want your house to be cool, you want your car to be charged, you want,
and I don't want
your phone to be charged.
That's right, and I don't want my clock to be blinking at me. I don't want that clock to blink at me. So
You're right.
So what do we do?
So previously the answer had been let's put a lot of sensors out there and let's try to put complicated systems, and then you're thinking about hardware rollouts and they take forever, and in the meantime you have your transformers already blown up and so forth. Or you have connection queues of interconnection requests, you can't put this EV on there, you can't do this, a lot of renewables queuing. So what we're proposing is, with smart metering being very prevalent, and I'm not even talking about AMI 2.0, you can use those as a sensor. And if you then match that with the grid topology and the understanding what meter this is, what pole top transformer this meter is connected to, and if you understand what this pole top transformer, how it's rolling up to a substation, you can actually just see it. You're turning a blind spot into insight without adding any hardware, and with just applying the means of software and using the data that you already have.
And because they're already smart, I remember back then when we started to deploy smart metering, that was a big deal. That is nothing now. Homes have smart meters. And so you're able to, with your solution, with your capabilities, be able to glean insights into what's taking place with that smart meter and collectively look at it from a holistic perspective.
Yes. In essence, you take the smart meter data and disaggregate it to see, is there an EV and what type of load pattern does the EV have? Is there PV? What type of load pattern does that have? Are there other heat pump type things? What's the load pattern of that? So you disaggregate that, you understand the patterns, and you understand previous violations, so you can see how many times, what duration has your transformer, your substation been suffering from limit violations, and you can make predictions, and you can understand, we call that the grid impact score, you can understand which asset is running closer to a failure, and you can understand what's a good time frame for a replacement, and also what's a good sizing for a replacement. So you're de-risking the whole story.
All I can think of, Sabine, is the amount. It's like it's dynamic. It changes dramatically on a daily basis as you continue to say, hey, EVs are good, go get EVs, go get EVs. You market, there's a demand for EVs. Yes. There's a demand for smart stuff, and which then increases the demand on the grid itself.
Correct.
I don't know how does your solution deal with the dynamics? It's just so dynamic. I don't know how else to put it. It's just all over the place.
The information of whether or not you have an EV or you have a heat pump is interesting, but by far not enough. What you need is the actual time series of the behavior, and you need that near real time and the historic data.
Right.
And then you can learn from it. You can say, this transformer has been violating a load limit for so long, because you know the time series, you know has been happening, and you actually see it. And I think why software is so important, software is a great thing to reduce complexity for humans. So if the software is doing the sense making and just giving you, this is the grid impact score, this is how much you are at risk to run this asset to failure, then all of a sudden it's becoming very simple, because the software and the AI in it is there to do the sense making, to do the analysis, and to analyze. It's millions of data points.
Yeah, absolutely, and that's what overwhelms me. How do you deal in the world of? See, Siemens is a very nimble company, as I view from afar. Right, nimble. That's great. How do you deal with the disconnect between utilities, regulators, not so nimble? But this is happening. Are they becoming more aware? I know they're aware, but it's happening.
We come from Grid Software Summit on Monday, and Barbara Humpton, the president of Siemens US, said a great thing. She said, what it takes is leadership. And you have great leaders in utilities, and those leaders pave the way forward. So we had Paul Lau on stage from SMUD, and what an impressive leader.
Wow,
and
really?
Really somebody who's a visionary and who So you definitely have those leaders in our industry, and the essence is to collaborate, to work together among leaders, shape a joint vision, the vision that we actually see is one of autonomous grid management. And if we gather around that vision, if we have leaders agree on what's the North Star, what's the direction of travel, then the only way to move something in this industry, as you rightly said, is by partnering, by working together, and by just leading the way, paving the way, literally, for others to follow.
It always gets down to the human equation.
Yeah.
It always does. And you're right. You're going to have somebody or group of individuals that are leading the way. I like the term autonomous grid management because from my perspective and my understanding back when, it was pretty straightforward from a grid perspective. Generation, transmission, distribution, substations, load, demand, managing, supplying, and all of that good stuff. Easy. Relatively easy. Very important. That's not the case. And it has to be. There is no way that a human can make those instantaneous adjustments to the grid without some software.
Correct. I mean, what I said on Monday was we got to flip our thinking for grid management on its head. So far, as you were precisely describing, the whole paradigm was one of top-down.
Yep.
Big generation, sophisticated transmission, and then statistical load profiles to distribute.
Just a linear shot, man, just like all the way down to that plug.
And if we look at the sheer number of distributed energy resources out there, we were just talking about Texas. There was a forecast for one day, and they missed the mark by 5 gigawatt because there was distributed energy resources that they were unaware of.
No way.
And if that is true, then already we are at the point where what's happening at the distribution grid is so significant in scale that how can we afford to continue to think top-down? We need to rethink it entirely and build it back up, bottom-up. And if you do that, the only conclusion that you can come to is that a human brain can't do this.
No.
It's millions and millions of assets who are independently behaving. And if you go into a control room these days, a control room operator already is bombarded with alarms.
Yeah.
They have 15 screens there, and now tell them, oh, we have more information, more alarms, more screens. Can you please continue to manage this safely? The stress under which these operators are is insane.
And you can't make mistakes.
You can't.
You just can't do it.
Yeah. I mean, we've seen, that was Brazil, but we've seen riots in the streets because outages weren't solved, communication to the consumer wasn't done well. I mean, this is a societal, like the coalition in society is affected if you don't provide power.
And because you're absolutely right. And because of that volatility, right? Whatever efforts you're making, whatever innovations that are happening, if you don't get the people part right, it's definitely going to impact the progress of whatever is taking place. Because I'm going to scream bloody murder, and everybody else is going to scream bloody murder.
Yeah, 100%. And that's why the way that we're seeing is you need to, I mean, autonomous grid management, I always put the analogy of autonomous driving, right?
Yeah.
So when first somebody said, oh, we will have autonomous cars, people said, oh, I'm scared, this is risky,
yeah, that's right.
This can't happen. But what happened in the meantime is that, I mean, no way you jump from level 1 to level 5 autonomous driving in one step. But, I mean, who wants to miss their kind of assistance systems, their cruise control, adaptive cruise control systems in their car these days? It's like helps you reduce complexity, it helps you in very bad traffic, it helps you to reduce the load on the human quite significantly, and it asks for intervention when the cruise control itself isn't sure enough. And that's the same thing that I'm expecting for grids. I'm thinking of a co-pilot type weight, much like the cruise control.
Yeah.
Like in normal conditions, no critical infrastructure, why wouldn't the system be able to do that? Like still observed by the operator and asking the operator if maybe there's a critical infrastructure, if there's something weird. But that's the only way, step by step, going from level 2 to level 3 to level 4.
It is, but you have to move. You have to do it. You just can't. It's not a big bang solution. You can't do that.
And what we believe that what I've been just describing about understanding the behavior of DRs is really the foundational step
for
to
clarification.
get there.
DR.
Yes, distributed energy resources.
Thank you.
Of course.
I knew it, but I was because I was getting. And what about distributed? What about the yeah? But that's good. Good.
That's
yes,
lingo, right?
Yeah, that is. That was lingo. But that's true. It's a must.
Yeah, it all starts from there. That's about kind of flipping it on its head.
That's big time flip on the head.
Yes.
All right. How do people get a hold of you, Sabine? This was a great conversation. You never disappoint. This is the second conversation. You didn't disappoint the first time. You never disappoint. How do they get a hold of you? What's the best way to be able to?
Go to Siemens.com. I mean, we are featured big time there for everything we're doing here at DistribuTech. And you'll find me on LinkedIn, of course.
Awesome. That's Sabine. Siemens Grid Software. Got it. Siemens Grid Software. Check them out. Go out to Siemens.com. We're going to have all the contact information for Sabine out on Industrial Talk, so fear not, you'll be able to connect with her and the rest of the Siemens team because they're cool. They're a cool team. All right. We're going to wrap it up on this side. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
You know what the game is? The game is about education. The game is about collaborating. And definitely the game is about innovation. Pulling all three of those together is critical to your success. Sabine is a great example. Siemens Grid Software absolutely reflects all of that. This is a must connection. We're going to have all of the contact information for Sabine out on Industrial Talk. So again, it's a collaboration game. Team Siemens is here for you and your success. And I am so thankful that we have companies like Siemens that are leading the way in how we modernize the grid, which, as she put it, just doesn't cut it anymore. But anyway, Siemens Grid Software, Sabine is the contact. Make it happen because you will not be disappointed. Be bold, be brave, dare greatly. Go to DistribuTech next year and you'll be definitely satisfied. We're going to have another great conversation shortly, so stay tuned.